This time only the domain is picture, then you have to figure out um, all these bounds. And I would say because you have this vertical side, painting this vertically upwards is easier. So if I were to integrate this function over this domain, I would definitely be using dy dx over dx dy. If you try to paint it horizontally, then you'll end up with two integrals, and it's quite hard to actually do the calculation. Okay, so we're going to do this, but the problem is we need to know these equations. Well, since it's a line passing through the origin, I know that they both look like y equals to mx, right? And m is a slope, so all you need to do is rise over 1. So the bottom one here, you go up 1 and then run by 4. So rise over 1 gives you y equals to 1/4 of x. Whereas this one, you rise by 3 and you run by 4, so the slope is 3/4, so this one would be y equals to 3/4 of x. Okay. Knowing that, now when you paint upwards, you start from this curve and you end at this curve, right? So you start at 1/4 of x, or y equals to 1/4 of x, but you don't have to put y equals because you already have dy. Having dy means automatically you interpret it like y equals 1/4 of x, which is this line. Okay, so you start from this line, and you end up at the other line. The other line is 3/4 of x, and you're integrating 38y e to the x, and then after that, after you integrate, what's the values for x? See, inside you have to do curve to curve, then outside it has to be a number. It should never be functions here, okay? So it's a point to point, and it's more like this. If you integrate vertically, then you're really adding everything up and placing on this right here. So it's like there's some machine here which flattens things down right here, and they have different density. You have more stuff here because it came from something higher. Okay, so if you have that, now you can just add up in the x direction. X goes from 0 to 4, right? So you integrate from 0 to 4. Okay, let's integrate by y. Integrating y by y gives you 1/2 y squared, right? And e to the x is considered as a constant because in the double integral, it's like the opposite of the partial derivative. So it's like a partial integral. So you treat e to the x as a constant. So e to the x is just a constant multiple, which I don't care. I'm just integrating y, which gives you 1/2 y squared. And then you plug in 3/4 of x and 1/4 of x, and the result again has to be integrated from 0 to 4 of dx. Now 3/4 squared gives you 9/16 x squared, whereas 1/4 of x squared gives you 1/16 x squared, and when you subtract them, you end up with 8/16, which is 1/2 x squared. Okay. So you end up with 38 times 1/2 x squared e to the x, integration from 0 to 4. 38 divided by 2 is 19, so I pull the 19 outside the integral. So 1/2 and 38 canceled, so we only have x squared times e to the x dx. Okay, so this one I'm just going to use tabular integration. Hopefully you know tabular integration. If you don't, just look at my channel. It's a really nice way to integrate things in place of integration by parts method. So you can solve this by using integration by parts twice, but that takes a long time. Tabular integration is equivalent to integrate by parts, meaning that anything that you can solve with integration by parts, you can solve using the tabular integration. But in many cases, this is faster. Not always, but in many cases it's faster. So what you do is I choose to differentiate x squared and integrate e to the x. And if you place x squared in the differentiation column, then you keep differentiating until you hit 0. And then you integrate e to the x, e to the x, e to the x, and then you do plus, minus, plus, minus. Okay. Alright, then after you're done with this, you do something like some kind of missile coming down, right? Some ballistic missile here. X squared times e to the x, and then you multiply here, which is negative 2x e to the x. This first column is alternating signs starting from plus, so if you multiply negative times 2x, that's negative 2x, right? And then 2 times e to the x. Whereas if you multiply like this, that's 0. You're integrating 0, which gives you just a constant, but we're doing a definite integral, so constants don't really do anything. So we only play with this one. So what we have is 19 x squared e to the x minus 2x e to the x plus 2 e to the x, and then to e to the x we have to plug in 0 and 4. I can factor the e to the x out before plugging in the values. I think that makes things easier. So it should be x squared minus 2x plus 2 e to the x, and you have to plug in 4 and 0. Now if you plug in 4 squared is 16 minus 8, so that's 8 plus 2, that's 10 times 9, so it's 19 here. 10 times e to the 4 is what you get. And when you plug in 0, you get e to the 0th power, which is 1, and you get 2, so you subtract. Okay, so that's the answer.